Alright, in this lesson, we will continue with the resource book. This is page 17 of your resource book, okay? More practice questions on bearings. So, this is the question. Find the bearing of B from C, C from B, okay? And you're given this diagram. Now, how do you do this question? I've transferred the diagram to this sheet of paper already so that I can write on it. So, this question is exactly the same as what you see here. Now, firstly, you take a look. There are points A, B, C, D, and this is the north direction. If this is the north direction, every line that is parallel to this line ACN, right, is pointing in the north direction. Okay, the tip of my pen. Now, I want to find bearing of B from C. From C means I focus myself at C. I stand here, I look north, okay, and I start from north, I turn until I see B. Alright, so it's actually like that. I look north and I turn until I see B. This is the angle that I want to find. Now, how do I find this angle? Actually very simple. This is given to you 90, 50, 50, so 180 minus this, you will get 40. And of course, this 180 minus 40, you will get 140. Okay? Now, don't you agree that the answer is just 140? Alright? So, the next thing they want you to find is bearing of C from B. From B means you must stand at B. You look north. Where is north? North must be parallel to this particular line. Okay? So, I draw it longer, cutting through B, and as I mentioned, you can draw this to help you understand that this is actually 90, 90, 90, 90. In certain questions, it's useful. Okay, now let's label this as north first. Okay, so we mentioned in class that whenever you have a north line, okay, north line here, okay, these two lines are parallel, and when these two lines are parallel, you look out for interior angles. You have one here. You can also look out for the Z, okay, which is alternate angles or parallel lines. Okay, so firstly, let us try and label the bearing, the angle. C from B. You stand at B, you look north, you turn until you see the C, which is all the way up to here. So don't you agree that the angle is this? Okay, and if I know this, okay, which is actually just 40, I take 360, which is angles at a point 360, one full cycle. 360 minus 40, that will be my answer already. Okay, so the answer for this is actually just 360 minus 40, which is 320. Okay, now that is for question number 1. We'll go now to question number 2. Question number 2, I've transferred it to here already. This is the question. I have transferred it to this sheet of paper, then I can work on this sheet of paper. Bearing of R from Q. From Q, again, let us stand at Q. Okay, there is no north line at Q, so north direction, so I draw this north line pointing in this north direction. So this is north, this is south. Okay, then as a beginner, I draw a horizontal line, okay, so that I know that it's 90, 90, 90, 90, 90. Okay, sometimes it's useful, sometimes it's not. Okay, now, bearing of R from Q. R from Q. So I'm at Q, I look north, okay, I turn until this pen is in line with this line from Q to R, because I want bearing of R from Q. It's like as if I'm turning and then I stop once I can see the point R. So this is the angle that I want. Is there a fast way to find this angle? Let's try to use the Z. Okay, I can I can find Z, okay, if I know this. Actually, I can draw a line down. Do you know I can draw a line down? And actually, I can from here find alternate angles, but it's easier to 360. Okay, so I'll just take 360. Okay, so this, if I call it alpha, right? Alpha will be equals to 360 minus 100 minus 120, and that will give me 140. Okay, yeah, and that is my angle alpha. I can just label here 140. Now how does this help me? If I know that this is 140, this red angle plus this red angle, they are interior angles of two parallel lines, so they add up to 360. This red angle and this red angle here. Okay, so my bearing, right? Okay, my bearing of whatever will be equals to 180 minus 140. Okay, this is applying interior angles of parallel lines. Now this will give me 40 degrees, but as I mentioned to you, if you simply write this as the answer, you will not get the mark, because bearing must be written as a 3-digit number, okay, for exact answer. Okay, now once I found this, I label here because I may need this in the later part. Now, bearing of Q from P. Bearing of Q from P. Okay, I am at P now. I stand at P. I look north. Okay, north, north, north. They must be parallel, these three lines. I turn in the clockwise direction until I see Q. Alright, now is there any way for me to find this angle and this angle? Because if I can find these two, I will be able to take 360 minus these two, and that will give me the bearing. Okay, now obviously you can find, right? Because as I mentioned, when you have two parallel lines, the two angles that are in between them add up to 180, which means that this angle, if I call it alpha again, this alpha would be 80, correct? Okay, then I put here 80. It's good to label whatever you have found on your diagram, update your diagram. Okay, then because this, let's call it beta. Okay, this beta, this must be beta because they are isosceles triangle. Beta will be 180 degrees minus 120 over 2, because these are base angles of an isosceles triangle, and you will have 30 degrees here. Okay, and now that I know that this is 30, this is 80, does it make sense? This plus this is 110. Yes, right, because 90, if I were to draw a horizontal line across, right? Okay, 90 is here, so 110, it makes sense that 110 is this angle. Okay, yeah, so how do I find this particular one? You take 360 minus this, and that will be your bearing of Q from P. Q from P, so is this angle here. So I take 360 minus 80 minus 30, and that will give me 250. Okay, yeah, so that is all for question number 2. Let's go now to the next page. Okay, the next page, I've already transferred. You turn your page to page 18. Yeah, okay. This is the question, okay, that you are given. Now you want to find bearing of R from Q. So how do I find R from Q? You go and stand at Q. Okay, look for the north direction. North is here, so you draw. Alright, label north, so that you know very clearly that this is north, this is north, and then you see 50 degrees. That means this must be 130, right? Okay, Now let's see what they want first lah. R from Q. R from Q. So I look north, I turn until I see R. That means I want this angle. And this angle you can see if I were to draw this horizontal line, right, it has to be more than 90 degrees. Okay, and how do I find the value? As I mentioned just now, I know from here these two are parallel lines. Okay, and in between two parallel lines, these two angles, right, the one that I shaded in red, they are they are going to add up to 180. So this, if I call it alpha, right, this angle is going to be 130. So this alpha is okay, and I label on my diagram. Now once I know this, right, I can take 360 minus this, and that will be my answer. Okay, I label in the blue. Okay, so my bearing, this working comes before this particular working here, and I will have 360 degrees minus 130 minus 127. Okay, and that will give me, let me see, 257. So 103. Okay, we double check. 257 plus 103 is 360, right? Okay, go and double check. Okay, now once I have this, right, I will label here, update my diagram because I may need it in the later part. I don't know, I just label. Okay, length PR is here. Now to find this length, you look at this triangle here. Okay, so remember we have mentioned this many times. Now maybe this is a good time to do some revision. Yeah, given you this, right, so this is the main thing about bearings, and then these are the useful things about bearings. These two add up to 180. This Z this Z here means that this alpha is 120. Similarly, there's a Z here, so these are alternate angles also. This will be beta if you want to find this angle. Okay, and then we mentioned that for trigonometry, this whole topic, right, you look at the triangle because this length belongs to this triangle, so you try to make use of this triangle to solve this question. So ask yourself, is it a right angle triangle? It is not, so you try to use sine rule. Sine rule, this one is friend with this one, very good, but that's all. We don't know this. There's no way to find this particular angle, there's no way to find this particular angle, so we cannot use sine rule. Okay, you double check. You see here, right, any way for this to be linked to this triangle, like 50, this is 50, I can actually find this angle. And once I can find this angle, I take 127, the big minus the small, then this will be 77. Okay, 77. Then after that, I still can't really find this particular one, you see. Okay, I can't find this angle. I can't really find this angle, or can I find this angle? You go and think about it. Is it possible to find this angle? You will find that it's easier to use. Actually, it's very obvious. Cosine rule. Okay, because the monster is here, right? Okay, with the two arms. I hope you can see that. Okay, then this is the tongue of the monster. So the victim is the PR square. Okay, and then you square the two arms as if it is like Pythagoras theorem. Okay, then now crime and punishment, you caught the monster already. You cut off the two arms. These two, don't forget, cut off the two arms. 12, 4. Okay, then cut off the tongue. 127. Okay, then when you take square root, of this whole thing, right, PR, don't forget to remove this once you take square root. Okay, you can actually write this whole thing down. Okay, don't need actually to evaluate. But you must practice using the calculator. You try and see whether you can get the answer should be, I've written here already, 14.757. Okay, then you round off to 3SF. Okay, but because actually this one is the last part of the question, actually no need lah, but I'm just trying to show you if this is part B and then there's a part C, right, you should write this down because most of the time you need this value to find the next one. Now for this question, right, let me see, is there unit given? There is unit given, kilometers. Okay, so because there is unit given, you have to write kilometers here, and you write here 3SF. Okay, because this is a length, so it's 3SF. Only when it's angle in degree, then you round to 1 dp. Okay, and the other thing you need to take note is actually if you write an equal here, right, you must state the accuracy lah. But if you write like that, then you don't need to write this. Okay, but if you write equal, right, it will only be equal to this. When you round off to 3SF, then you must write this. Okay, so you can either write this or you can write this. Either one, either one. So if you want to save time and all that, right, you can just write this. No need to write this. Alright, but personally, I prefer to write this. It's up to you. Okay, now the last question for bearing, before we move on to the next topic is what you call this? Coastal guard question. There are some coastal guards, okay, let me show you the question first, because you roughly need to do the story. Now the story is like that. A ship C, the ship is here. Okay, a ship C is spotted by 2 coast guards. These 2 are coast guards. Okay, the bearing of B from A is 37. Okay, you just verify that your diagram is correct and then you understand what's going on. BAC is 48, BAC is 48, no big deal. ABC is 97, ABC 97, no big deal. That one you all understand. Okay, so once you understand already, let's do the question. Okay, the question is simply like that. Oh, why did I copy the next? Okay, never mind. Bearing of A from B, bearing of A from B, meaning I think by now it should be quite good already. This whole angle, correct? Now this whole angle can be easily found if you know this angle, and this angle you know is related to this angle. Related how? They are there are angles that add up to 180 degrees. Why? Because they are interior angles. So this must be, if I call it alpha, this alpha must be 143. Okay. Alright, so this is 143. Now, once I know this alpha 143, I can find my bearing already. 360 minus 143, that would be my answer. Okay, and that will give me 217. Okay, so the bearing is 217. I write here 217. Now you see, if this is 217 and then this is 97, right, you can actually find this part here if you need to later. Okay, but never mind, for now we see what they want us to find for the second part. Okay, I forgot to copy the question. So they want us to calculate bearing of B from C. Okay, bearing of B from C, bearing B from C. Okay, now B from C means you are at C. You look north. You see all my north pointing in the same direction, and then you turn until you can see your B. So I turn until I can see my B there. Okay, now how do I do this particular question? Don't you agree that if I know this, then I win already? Why? How come I win? Because I can just take 360 minus this one, finish already. Alright, This is related to our friend here. Okay, so I hope you see how powerful interior angles and all that are. Okay, now I mentioned just now, right, if this is 271 and this big big angle is 271 and this smaller angle is hiding inside this big angle, right? So this part here must be 271 minus 97, right? Okay, so it will be 1 8 eh 271 minus 271 minus 97 174, sorry, 174. Okay, 174. Okay, the diagram does it look like 174? Okay, the diagram not drawn to scale but it's more than 90, so it can be 174. Alright, now this is 174. If this part here is 174, then this must be 6. Okay, the diagram very weird. Let me see. Did I make any mistake? 97 143. Okay. Oh, sorry, this one just now was 120, right? Okay, 120. Now here should be 120. Okay, and wait sorry, this is 217 217, not 271, no wonder. Okay, 217. Okay, so sorry about that. So this is 217. I wrote here 217. 217. Okay, sorry. So this is a good demonstration of careless mistakes. Okay, I have calculated here correctly, but when I wrote the answer here, right, just now I wrote 271, you see. So it's good to check your answer Okay, so although diagrams are not really drawn to scale, right, but just now my answer here after I calculated, it's like very unreasonably far off Okay, so I suspected something was wrong. Okay, so I hope that you can also practice this. Okay, let me just do a little bit of touching up so that you are not confused. Okay, sorry about the mess, but this is going to be what will happen in the exam. Meaning to say that you make some mistake. Okay, then you got to do some correction. Now here there's no mistake. I calculated correctly just now, but when I wrote here, right, instead of writing 217, I wrote 271. So I'm going to correct the mistake now. So 217 minus 97. Okay, if you to use your calculator, 217 minus 97, right, it is 120. This number is more reasonable Okay, if you look at the diagram. Okay, now how else can I get this 120? I can take 360, okay, minus this red one minus this blank one. So you see there are many ways to arrive at this answer 360 minus, that's what I did just now to find out whether I make any careless mistakes or not. Okay, so these are all things that you can do. So this is 120. Okay, now which means that the bearing so don't get confused. The 217 is the big one, okay, which is the answer for here, and then this blue one, right, is just this angle here. Okay, bearing of B from C here And I already know this is 120, so this must be 60. Cannot be 6 lah, cannot be 6 there. Based on what I can see. So this must be 300. Finish already. So this must be 300. Okay, you show the necessary working. Okay, I just showing you how to get the answer. So you see how powerful interior angles are. Okay, from here then we lead you to here. Now the third, is there a C? Okay, C, they say the distance AB is 20. Now did they label on diagram AB 20? They didn't, you see. So you need to always read the question, make sure that whatever is stated here is updated on your diagram. Alright, AB is 20, so I'm going to label there 20. Don't get confused also between length and angle. So if this is 20, I want you to find AC. Okay, then you know already. AC is this one, right? They want you to find this one. So you try to look for a friend first. Oh yeah, we have a friend here. Okay, and this angle you know, sorry, this length you know, right? So you must have this friend here. This is quite useless. This one you don't know, so no point pairing with this. Okay, so you take 180 because there are angles in the triangle. So 180. Okay, I can't show you on the screen. Okay, never mind, you just press 180 minus this, you get 35. So 35 is friend with this fella, and 97 is friend with this fella. So as we mentioned to you in class, this one is not a right angle triangle, so you try to use sine rule. And sine rule, you write the unknown here so that you can reach your answer in the least possible step. Okay, then sine of this. Okay, then this length 20, then sine of this. Okay, then you so-called don't cross multiply like that, then you waste time, manipulating and all that. You really want the unknown that is here. That's why I asked you to write the unknown at the top left corner, right? So that one step you get the answer already, which is this over this times sine 97. Okay, and then you press calculator. Okay, let us press calculator lah. Okay, 20 over this. Okay, then you go in times. You must practice pressing calculator. Don't just take my answer as the correct answer. My answer could be wrong. Okay, so this is what you have. 34 point. Okay, because this is the final part already, right? Is this the final part? AC is the final part already. So you can just write 34.6. The unit is kilometers, and you've rounded off to 3 SF. Finish. Okay, so that is what we have. Okay, we have about half an hour more. Okay, we now go quickly to just a introductory video on what we call angle of elevation and angle of depression. It's just a new, very simple sound.
Introduction to angles of elevation and depression. Every day, we look at different things around us. We look up to see things above us. We look down to see things below us. Angles are formed.
Okay, you see, normally, right, we as human beings, when you walk or whatever, right, we look straight one, right? We look straight. That means in a normal human state, when you're sitting down or whatever, right? Okay, in a neutral state, you will look straight, right? You look straight. You won't go and look up like that or look down like that. So we use this dotted line as the reference point for this new concept that we are doing. Alright? And later they'll explain to you, when you look up, this angle that is formed, okay, between this yellow dotted line and this white line, right, is called elevation, because you are like going up. You take elevator to go up, right, the lift to go up. So this angle is called angle elevation. This angle that is going down You see how when you're depressed, you look down, right? Oh, you see people who are depressed, they look down one. They won't look happy, they won't look up like that one. They will look down. Okay, so that's how you remember. D for depression. Then elevation
We
should
look
go up.
up or down, and these angles are called angle of elevation and angle of depression. First, let's follow Dylan around the park to see the different angles of elevation and depression. Dylan looks up at the bird on the tree. When he looks up, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked up at the bird. There is an angle here. We say this is the angle of elevation. Elevate means to lift up. With this angle of elevation of the bird from Dylan, he takes a close shot of the bird. Next, Dylan now needs to locate the crocodile farm. He sees a signboard and he tilts his head. Again, there is an angle of elevation of the signboard from Dylan's eyes. Remember, Dylan was looking straight like this just now. Then he looked up at the signboard. There is an angle here. This is the angle of elevation. Dylan cannot see the words clearly. He walks nearer to the signboard. The angle of elevation of the signboard from Dylan increases as he walks nearer to the signboard. There it is. The crocodile farm is over there. He walks to the crocodile farm. At the farm, he sees the crocodile and he looks down at it. When he looks down, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked down at the crocodile.
Okay, just want to highlight to you, always right, the angle, elevation or depression must start from this horizontal line, okay, and then this is the angle, okay. A common mistake by some students, right, is they thought that this is the angle of depression. Okay, it's not. Okay, it must be measured starting from, it's like your bearing, you start from the north, right, north line. This one you start from the horizontal line. Okay, because normally we'll just look straight horizontal. Okay, I clicked wrongly. Okay, never mind, it's here.
Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked down at the crocodile. There is an angle here. This is the angle of depression. Depress means downwards. With this angle of depression of the crocodile from Dylan, he takes a picture of it. He walks a few steps on the platform and sees a mud skipper opening its mouth. That is a rare sight. He tilts his head down to capture the picture. Again, there is an angle of depression of the mud skipper from him. This angle is larger than the angle of depression of the crocodile.
Okay, so this is a very important concept. You can see that when things are far away, right? When things are far away, let's say there's something here. Okay, something here. After the crocodile, right? When I look at it, right, it's here. So you see the angle of depression is not much. But when the thing is very near you, then the angle of depression will be very big. Okay, let's say there's something here. Now, let's say he's looking here. You can see that, oh yeah, even greater, you see? Okay, so we can set questions like this. Next time I'll show you. This is very big angle of depression here. You see this angle so big? Okay, if he's staring at something here, alright?
Crocodile from Dylan. Because the mud skipper is nearer to Dylan, he took a picture of it. Now that we have seen angles of elevation and depression like these, do you notice any similarities in them? Notice that both angles of elevation and depression have a horizontal line. Notice there is also a line touching the horizontal. It is this line that connects the object from the observer's eye. It's called the line of sight. Thus, an angle of elevation or an angle of depression is between a horizontal and a line of sight. The angles are also at the reference point, and the word from is important to determine the reference point. Adding on, is there any relationship between these two angles? Let's continue following Dylan to find out. Dylan sees a squirrel on the tree. There is an angle of elevation of the squirrel from him here. Let's draw the horizontal and line of sight. Can you identify it? It is here. Interestingly, the squirrel looks back at Dylan. There is an angle of depression of Dylan from the squirrel. Let's draw the horizontal and line of sight. Can you see it? It is here. Since both horizontals are parallel and are cut by the same line, these two angles are equal.
Okay, so just to take note, when this squirrel is looking at, in normal state, right, this squirrel will be looking straight lah, Then suddenly this Dylan appeared, When the Dylan appeared, right, the squirrel will have to look down. This is the angle formed, okay, in order to see Dylan, alright. Whereas Dylan has to, he was looking straight at first, and then he has to look up, right? So it forms this Z, okay, and these two two horizontal lines, of course, they are parallel. So this angle, the value, is equals to this angle, the value, okay. But if I were to ask you for angle elevation, you must label it as this one, okay. If I ask you for angle depression, then it is this one, okay. But what I'm trying to say is that the two values are the same lah. If this is 20, this is 20, okay. But when we say angle of depression, you cannot say this is angle of depression, cannot, okay. You must say this is angle of depression, okay, of Dylan from the squirrel. This is the angle of elevation, okay, of the squirrel from Dylan, alright. Okay.
Dylan takes a picture of the squirrel and walks on. All in all, when we look up, an angle of elevation of the object from us is formed. Specifically, angle of elevation is the angle between the horizontal and line of sight. When we look down, an angle of depression of the object from us is formed. And an angle of depression is the angle between the horizontal and the line of sight too.
Okay, so very simple, this concept. This new concept, right, you can actually put it down in your notes, okay? Now, everybody, it's good to make your own notes. I've made my own notes, but you may not be able to associate with my notes, okay? Now, what we have learned new just only, is this concept, angle of elevation, angle of depression. It's always measured from this horizontal line. That's all, okay? After that, you just use either right angle triangle, okay? Most of the time you can use right angle triangle for this, you know why not? Because there's a right angle when you draw a vertical line down, okay? But if cannot, right, there are cases where cannot, then you use sine rule, cosine rule, you go by that order lah. Okay, so we have learned bearing, okay, we have learned this last year, okay, which I revised with you in the last week, I think, and then down this one, okay. Now we are going to see how we can explore more on this particular topic. So let's say your angle elevation, right? Okay, let's say I tell you the angle elevation of focus a bit, B from A. From A means you are at A. It's just like bearing of B from A. That from wherever you're from, that means you are there lah. You are there, right? Okay, so if you are there, this is the ground, okay, ground. This is a pole. Now a pole, where the pole meets the ground, right, it will always be 90 degrees, because a pole, if they just say vertical pole, if they say vertical pole, right, that means the pole is standing vertical so you can straight away say that this is 90 degrees. Okay, and because it's 90 degrees, right, you can use your Tuakaso Pythagoras and all that. Okay, so that's why this diagram all very important. Actually, this is the whole mind map that you must know for this topic. There's one more topic on three-dimensional diagram. I will add in now when we study it. Very simple one, three-dimensional, very simple. Okay, so find the angle, angle elevation of B from this one means when I stand here, I look straight, this is my horizontal line, right? In order to see B, I must look up, right? So this is what we call the angle elevation. Finish. Just to tell you like that. And then this angle is 50 degrees. And then from here you can use tuakaso lah, whatever to find this length lah, whatever. Okay. Of course, this is just an example. I didn't give you enough information to find this lah. Okay, but now if let's say I want you to find the angle depression of A from B. So now you're like the squirrel. You're standing here. You need to look in the direction of this fella, but you look straight first. That means you're standing here as if your eyes are here. Okay.